Good morning, children. Yesterday we worked on first chapter and I hope that all of you have completed the exercises from first chapter. Today we are going to begin linear equations in two variables. Linear means a function or a polynomial with degree 1. When you say degree, it is the degree of the variable, the degree of the unknown. Like if you see root 2x plus root 3y is equal to 0. We call this as linear equation because the degree of x is 1, degree of y is also 1. And there are two variables. Therefore, it's a linear equation in two variables. It's an equation because there is equality. So, even if you see this is also a linear equation in two variables because when you say degree of x or degree of y, that's 1. Degree of constant term does not matter. Like here if you see the power of 2 is 1 by 2. It's okay, it's still a polynomial because when you talk about a polynomial or an algebraic expression, we look at the power of the variable. There are various methods of solving linear equations in two variables. Today we are going to learn the method of substitution. Now, substitution, that is, if something is missing, you substitute it with some other thing. In the same manner, we are going to substitute either x in terms of y or y in terms of x and find the solution for the two equations. These two equations are simultaneous linear equations. They will have a unique solution. They will have a solution that is the value of x and value of y, which will satisfy both these equations. So if I take the first equation, root 2x plus root 3y equal to 0, and I have the second equation, root 3x minus root 8y equal to 0. Suppose I decide to substitute x in terms of y. So I get x as minus root 3y upon root 2. This x from this equation I substitute in this. So root 3 x is minus root 3y by root 2 minus root 8y equal to 0. Now I can take y common. Root 3 into root 3 is 3. So minus 3 by root 2 minus root 8 equal to 0. Now we need not solve further because anyway this term is not 0. Product of two terms is 0. That means one of the term has to be 0. This is a constant term. It's not equal to 0. So y has to be 0. So this implies that y is 0. Now y is 0. If I put here, I get x also 0. That is the solution for these two linear equations. X and y, we always write x first and then y is 0, 0. Linear equation in two variables will have a unique solution, or it can have infinite solutions, or it may not have solution. Here we are getting a unique solution by solving by substitution, right? Now when you solve by substitution, we can work on one more question, and then I want all of you today to work on complete exercise 3.3 and call me for doubts if you have any. We are not going as per the order of the textbook. We are going to learn these methods, one method, one day. Now if I have to work on this, 3x minus by 2 minus 5y by 3 equal to minus 2. So what I will do is 3x by 2 plus 2 is 5y by 3. I am going to substitute y now. 3x plus 4 by 2, I have taken LCM, into 3 by 5 is y, right? So y is 9x plus 12 by 10. This y I substitute in the second equation now. So I have x by 3 plus y by 2. So 9x plus 12 by 2 into 10, 20 is 13 by 6. And now all of you know how to take LCM and solve. Get x from this solving and substitute this x here to get y and then get the solution. It's all algebraic solving. So today you are going to work on method of substitution for solving linear equations in two variables. Tomorrow keep your graph notebooks, pencils and scales ready because then I will teach you the graphical representation of linear equations and their solving. Today's your homework is exercise 3.3 complete. Yes? Bye and take care of yourself. Remain at home.